The whole crew saw a whole bunch of silver darting objects. And he says they're doing the strangest thing. They're going like to this peak in a group, to this peak in a group, and then they'd all take off.
The renowned astronaut Cassidy reported to his ground team that something horrifying is heading to Earth right now. Many experts dismissed this unknown object as possibly just some drifting debris, but they couldn't be more wrong. This unexpected sighting quickly stirred up intense discussions among scientists and UFO enthusiasts, raising global alarms. Why are the world's most powerful armies targeting this alien visitor as a global threat? Let us explore why NASA will shut down operations after spotting this suspicious object targeting our planet. What lies beyond our sight? At a later media briefing explaining the incident, Cassidy calmly proposed that the object was probably just a stray piece of insulation or a light cover that had come loose from the station itself. This rational explanation may seem less thrilling than some might hope, but it underscores a common element of space travel: the debris that accumulates around human-made spacecraft. The space station itself, as large as a football field and weighing around 1 million pounds on Earth, is a monumental achievement of international cooperation involving countries like the United States, Russia, Japan, Europe, and Canada. It serves as a base for astronauts and cosmonauts to perform experiments in a variety of modules and labs, powered by large solar panels and equipped with robotic arms for construction and maintenance. Yet, it's not just the scientific and cooperative aspects of the ISS that pique interest. The docking ports of the station, which welcome astronauts and spacecraft, sometimes become the subject of lively discussion due to the unusual objects reported approaching the station. Official explanations often dismiss these as mere interactions with commonly found space junk or minor technical issues. But such explanations do not always satisfy the public's curiosity, keeping online forums and discussion groups active with speculation. The intrigue is further fueled by the Columbus Eye cameras, high-definition devices installed on the station in April 2014. These cameras stream live footage of the surrounding space back to Earth, viewable on a university-hosted website. This continuous, clear view allows people to watch the space station's environment and spot any irregularities, whether a brief flash of light or an unexplained shadow, keeping the dialogue about these occurrences alive. Interestingly, the cameras on space missions do more than just send pictures and videos back to Earth. They are also tested to see how well they can handle the tough conditions in space. However, there are some who accuse NASA of turning these cameras off during live broadcasts to prevent the public from seeing everything. This concern has grown especially around the sightings of unidentified flying objects, with some people suggesting that NASA only shows us what they want us to see. The ISS plays a critical role in advancing our knowledge of space and science, showing what can be achieved through international cooperation. It has become a hub for a wide range of scientific research, from studying human health in space to testing new technologies. The information gathered here will help shape the future of human space exploration, inspiring us to reach further into space. Such stories fuel ongoing discussions about what might be hiding in the depths of space and what is being kept from public view. The mix of groundbreaking science aboard the ISS and the historical intrigue of UFO incidents like the Mantell incident invites us to question how much we truly understand about the surrounding universe. The wake of the crash, the Air Force initiated a thorough investigation to uncover the nature of the object Mantell pursued. Initially, there was a flurry of speculation. Some believed it was just a weather balloon, while others entertained the possibility of it being something more unusual, possibly even extraterrestrial. Later, it was suggested that the object might have been a skyhook balloon. Debates intensified as new questions arose. The silent space detectives. Some critics argued that the military was perhaps covering up the true details of the incident. They suggested that the explanations provided were too convenient, masking the real details of what Mantell had encountered. There were also those who speculated that Mantell might have been confused. Years later, the Unidentified Aerial Phenomena Task Force was created by NASA in 2021 to investigate similar unexplained aerial sightings. This group, in collaboration with the U.S. Department of Defense and the Federal Aviation Administration, aimed to analyze these occurrences thoroughly. focusing on their characteristics and any potential threats they might pose to safety. Importantly, their goal was not to uncover proof of alien life, but to understand the nature of the sightings. The task force adopted a detailed and systematic approach, gathering data from various sources, including military and civilian pilots, radar systems, and satellites. Despite their extensive efforts, the outcomes were often inconclusive. Their preliminary report in 2022, after examining 144 sightings, concluded that, while about 80% could be attributed to natural or man-made objects like drones or balloons, the remaining 20% had no clear explanation. This group of unexplained cases included the notorious Tic Tac incident of 2004, where Navy pilots witnessed an object performing maneuvers that seemed to defy known aviation technology. This object, like many others, was closely analyzed, but remained unexplained, underscoring the limits of current investigative techniques. As the task force continued its work, the balance between revealed and withheld information continued to stir public interest and discussion. A more detailed report was anticipated, expected to provide further insights into these baffling aerial sightings. Whether this upcoming report would close the chapter on these questions or open up new avenues for debate was yet to be seen. The UAP task force remains committed to its goal of exploring unexplained aerial phenomena that have intrigued both the public and experts. They are scrutinizing the gimbal and go fast videos from 2015, taken by Navy pilots, which have sparked considerable attention. There is an ongoing debate about the authenticity of these phenomena in an era dominated by digital tricks and advanced drone capabilities, which could easily distort our understanding of these events. Their approach to examining these sightings involves collaboration with other well-known agencies and relies on thorough analysis. Yet the true usefulness of these activities is up for debate. These efforts have yet to conclusively reveal the nature of the phenomena they investigate, leaving many questions unanswered despite rigorous attempts to understand them. Meanwhile, NASA's recent endeavor with the Lucy spacecraft brought something new to the table. During its first flyby of the asteroid Dinkinesh, Lucy discovered a small mini-moon orbiting the asteroid. This satellite, only 220 meters wide, spins around Dinkinesh, which itself is a relatively small body in space, about 500 miles in diameter. This observation was made from a distance of roughly 270 miles away. Keith Knoll, a project scientist at NASA Goddard Space Flight Center, expressed excitement about this being the closest encounter with one of the smallest main belt asteroids ever seen up close. This discovery might sound fascinating to those with a keen interest in space, but for many, the relevance of a distant asteroid and its tiny companion remains unclear. The enthusiasm from scientists like Hal Levison from the Southwest Research Institute, who found the discovery marvelous, highlights a disconnect between scientific excitement and public interest. Everybody might struggle to find the direct impact of such distant cosmic findings on their lives. As NASA continues its exploration, the Lucy spacecraft is set to have another close encounter with an asteroid in 2025. This mission serves as a warm-up for the spacecraft's future engagements with the Trojans, a group of asteroids near Jupiter. The mission initially targeted 7 asteroids, but has since expanded to include 11. This change reflects the growing ambitions of space missions, which aim to uncover more about the early days of our solar system. While supernovas are the explosive deaths of stars, the opposite process, star formation, is the birth of new stars from clouds of gas and dust. This process mainly happens in regions called stellar nurseries, or molecular clouds. These clouds, rich in hydrogen and other gases, slowly collapse under gravity to form new stars over millions of years. One of the primary tools for studying star formation is the Atacama Large Millimeter Submillimeter Array, which captures detailed images of dense, dusty regions where stars are born. ALMA's observations have revealed that within the spiral arms of galaxies, dusty masses collapse into planet-sized clumps. These observations show how gravitational forces lead to the formation of new stars and even planetary systems within these dense regions. Star formation often gets a significant boost when galaxies interact or collide. For example, the collision of galaxies like the Antennae and Mice galaxies creates tidal tails, long streams of gas and dust pulled out by gravitational forces. These tidal tails are fertile grounds for new stars, as the gas within them gets compressed, triggering a burst of star formation. The young star clusters formed in these tails are only about 10 million years old, indicating a recent and ongoing process of star birth. Additionally, new stars form from the dense cores of molecular clouds, where the conditions are just right for gravity to overcome the internal pressure and initiate the collapse. This collapse leads to the formation of protostars, which eventually become full-fledged stars as nuclear fusion ignites in their cores. Instruments like the Hubble Space Telescope have provided stunning images of these processes, showing the intricate and beautiful structures within star-forming regions. NASA's quest for answers led to surprising finds, the observatories at the frontier of space. While potentially offering insights into how our solar system formed, these missions feel detached from the immediate concerns facing humanity. Additionally, the acknowledgement of over 5,500 exoplanets by NASA underscores the vastness of our universe and the continuing expansion of our cosmic knowledge. The recent addition of 6 planets to NASA's exoplanet archive is a testament to decades of space exploration. Since 1992, when the first exoplanets were confirmed, astronomers have used both space and ground-based tools to find and study these distant worlds. While these achievements are celebrated within the scientific community, they often seem abstract to those not involved in astronomy. The high costs and extensive resources dedicated to such distant explorations provoke questions about their practical value. As space missions stretch further into the cosmos, their real-world benefits remain as elusive as the phenomena the UAP task force investigates, with promises of future insights that are yet to resonate broadly beyond academic and professional circles. The James Webb Space Telescope, often simply called JWST, has once again captured a fascinating cosmic scene, an image of the remnants of a star that exploded 36 years ago. This star, known as SN 1987A, is situated a staggering 168,000 light-years from Earth. The JWST's near-infrared camera has provided a new view of the expanding debris with remarkable clarity. This observation is part of a long-term study spanning nearly 4 decades, utilizing various types of telescopes to analyze the light across the entire electromagnetic spectrum, from gamma rays to radio waves. The recent images from the Webb telescope showcase intricate details of the supernova's aftermath. At the center of the image is a dense keyhole-shaped structure filled with gas and dust clumps, all that remains from the supernova explosion. You can't see through it, leaving a distinct dark spot in the middle of the keyhole. Surrounding this central darkness is a bright, equatorial ring that seems to bind the 2 faint, hourglass-shaped outer rings. These rings were formed from materials that the star shed thousands of years before it met its explosive end. These features now display bright spots where the shock wave from the supernova continues to collide with the previously ejected material, illuminating it against the vast backdrop of space. Despite the extensive research and observations over the years, astronomers have yet to confirm the presence of a neutron star, which is typically expected to form from the remnants of such a massive stellar explosion. This ongoing puzzle does not deter scientists. Rather, it fuels their curiosity and determination to understand the processes that shape such cosmic events. NASA has indicated that Webb, along with its suite of instruments including the Near-Infrared Spectrograph, NIR-SPEC, and the Mid-Infrared Instrument, MIRI, will maintain surveillance on the supernova. These instruments are expected to provide new, detailed infrared data that will help unravel the newly detected structures around the supernova and enhance our understanding of how these remnants evolve over time. Additionally, the Webb telescope is set to continue its collaborative efforts with other major space observatories like the Hubble and Chandra. This teamwork is crucial as it combines observations from various perspectives, allowing astronomers to build a more comprehensive understanding of SN 1987A and to fine-tune their models of how supernovae develop and influence their surroundings. On another front, NASA's Curiosity rover, which has been exploring the surface of Mars, has made a surprising discovery in the Martian mountains. As it climbs through the foothills of Mount Sharp, a 3-mile-high mountain previously believed to be covered with streams and lakes, Curiosity found evidence of an ancient watery past in an area where scientists had expected dry conditions. The rover uncovered rock patterns that suggest the presence of lake waves, pointing to the historical existence of significant bodies of water. This finding, described as the most convincing evidence of Mars's watery history discovered during the mission, suggests that Mars was once more similar to Earth, with a warmer climate and plentiful water, before transforming into the cold, arid planet we see today. These scientific endeavors, from examining distant supernovae to unearthing the watery history of Mars, reflect humanity's relentless pursuit of knowledge about the cosmos. Each discovery, meticulously documented and analyzed, adds a piece to the puzzle of our universe's complex and dynamic nature, helping us piece together the vast and intricate tapestry of celestial phenomena that govern the universe we inhabit. How do these space missions shape our understanding? The devastating life cycle of red supergiants. Patrick Kelly, who teaches astronomy at the University of Minnesota and contributed to the study, observed that the supernova changes as it gets cooler and bigger. Its colors shift from a vibrant blue to a deeper red, showing how the star is winding down from its intense phases to a quieter state. The star in question, called a red supergiant, spent its final days in a small, less noteworthy galaxy, ending its short life almost anticlimactic. According to Chen, another researcher on the team, red supergiants are big and bright stars, but they're not as hot as many other large stars, which is why they glow red instead of a fiercer color. They reach temperatures around 180,000 degrees, which sounds extremely hot. But in the world of stars, it's actually on the cooler side. These stars, with their impressive size and brightness, have a relatively short lifespan in the grand scale of the cosmos. Once they've used up the energy that fuels their core, their life cycle takes a dramatic turn. They don't just slowly fade away, instead, they collapse inward dramatically. This collapse is not a quiet surrender, but a chaotic and forceful event that leads to a supernova, an explosion that rips the star apart and sends its outer shell flying into space. This dramatic end is both a powerful and poignant reminder of the star's once mighty presence. The explosion is not only a significant event in terms of energy and brightness, but also a crucial part of recycling stellar material back into the universe, contributing to the birth of new stars. This cycle of stellar life and death highlights the ongoing saga of regeneration and transformation that occurs across the cosmos. About 6 hours after it first exploded, the initial image showed the star's blast was small but extremely hot, reaching temperatures around 180,000 degrees. At first glance, this might seem less dramatic, yet the intense heat indicated a violent end for the star. 2 days later, a second image was taken. It showed the gases thrown off from the star spreading out into space, cooling down to just a fifth of their original temperature. Another 6 days passed, and a third photo showed these gases had expanded even more. By this time, the temperature had dropped to just a tenth of what it was initially. Chen suggests that what we're seeing is probably the remnants of the star slowly fading away. This slow cooling and expansion might look simple, but for those who study stars, it's an important part of understanding how stars die. These photos are more than just pictures. They are important pieces of information that help scientists figure out how star explosions happen. From blazing hot to gradually cooler, this process is not just about the visual impact, but about the science behind what happens when a star ends its life. As this star remnant keeps spreading out and getting cooler, experts like Chen use this information to piece together the puzzle of the star's final moments. They view each stage of cooling not just as the end, but as a key event that helps us learn more about the universe. While we celebrate these observations as victories for human ingenuity and technological achievement, they also subtly remind us of our small role in the vast cosmos. We are essentially decoding the remnants of distant events, helped by cosmic structures whose immense scale and power far exceed anything within human grasp or understanding. This scenario unfolds against a backdrop of cosmic giants, galaxies, stars, and clusters that interact in ways that often go beyond our usual experience with physics on Earth. By studying the light from these stellar explosions, magnified and bent by the gravity of a galaxy cluster, astronomers can piece together the life cycle of stars and the dramatic events that mark their demise. These insights enrich our understanding of the universe and challenge us to think bigger about where we stand in relation to these monumental processes. We're not just passive observers. We're detectives piecing together the clues left behind by the universe's most energetic events. Such distortions tell us that what we perceive as the fabric of space is malleable, controlled by the mass of objects within it. Each cluster or galaxy that bends the light acts like a lens, focusing or dispersing the light from objects behind it. This effect allows us to study the universe in ways we couldn't if light traveled in straight lines. One famous supernova was observed in 1987, called SN 1987A, which gave scientists a lot of information about these explosions. This supernova happened in a neighboring galaxy, but was close enough for detailed study. More recently, the James Webb Space Telescope has been looking at the aftermath of SN 1987A, helping scientists understand what happens after a star explodes. Several supernovas have been recorded throughout history. In 10,006, a supernova was visible from Earth and was very bright. Another well-known supernova happened in 1054, resulting in the Crab Nebula. These events have been crucial for learning about the life cycle of stars. Supernovas can be dangerous to life on Earth. If a supernova occurs too close to our planet, it could damage our atmosphere and increase harmful radiation levels. This could lead to severe consequences for life on Earth. Scientists have found evidence in Earth's rocks that suggests past supernovas might have influenced our climate and biological history. In addition to supernovas, gamma-ray bursts are also powerful events in space. These bursts happen when neutron stars collide, releasing intense radiation. If a gamma-ray burst were to hit Earth, it could cause significant harm. Fortunately, these events are rare within our galaxy. Supernovas also affect the galactic habitable zone, the area in a galaxy where conditions might be right for life. The frequency and proximity of supernovas can make some regions less suitable for life due to their destructive potential. This has led scientists to rethink where life might exist in our galaxy. Astronomers are constantly watching the sky for stars that might explode. One such star is Betelgeuse, which is a red supergiant about 600 light-years away. Betelgeuse is expected to go supernova sometime in the future. Although it will be a spectacular sight, it is far enough away to not pose a direct threat to Earth. These new discoveries change our view of the universe. The echoes of distant supernovas. The multiple images of a supernova that we might see are not just duplicates. They are a gallery of time-delayed images sent through different routes. This cosmic spectacle is a stark demonstration of the universe's dynamic nature, where even beams of light must navigate the gravitational landscape. Understanding this phenomenon also underlines a broader theme in astronomy. Our observations are shaped by the interplay of light and gravity. As light from distant stars travels through the cosmos, it encounters numerous obstacles that alter its path, making our view of the universe a complex tapestry woven by these fundamental forces. Kelly called viewing the rapidly cooling supernova in a sequence of images absolutely amazing. She compared it to watching a film reel, observing the colors of the supernova changing. This gave a far clearer and more detailed view of this astronomical event from when the universe was much younger than it is today. However, to those who regularly study the stars, her excitement might seem a bit excessive. It's not uncommon for every significant space discovery to be touted as a major breakthrough in astrophysics. Though these images provide a detailed look at a cosmic event, suggesting an unprecedented clarity in our observation of the early universe, one might question if such enthusiasm is somewhat exaggerated to draw public attention or secure more funding. Indeed, while the data is incredibly detailed and will surely contribute to many scientific studies, the practical impact of these findings on our everyday understanding of the universe might not be as immediate or dramatic as suggested. These images, while stunning, represent just a single event in the vast tapestry of the cosmos. They are part of a broader scientific endeavor that continuously reshapes our understanding of space. As researchers, it's crucial to maintain a balanced perspective, acknowledging that while this discovery is significant, it is merely one of countless others that collectively inch us closer to a fuller comprehension of our universe. It's important to keep our excitement in check and remember that many more discoveries await us, each with the potential to challenge and expand our current knowledge. It appears that astronomers only manage to capture a supernova just as it's starting when it occurs relatively close to us. This fact highlights a simple truth. When we look at objects farther away in space, we're actually looking back in time. We're seeing the universe not as it is now, but as it was many years ago. These glimpses into the distant past are brought to us by our powerful telescopes and observatories, which, impressive as they are, come with their limitations. Understanding that we are essentially watching a replay of cosmic events that have long since concluded might seem a bit disheartening. We're not catching these events live. Instead, we're latecomers, just getting our tickets to a show that ended ages ago. This realization doesn't necessarily lessen the importance of our scientific endeavors, but it does paint our celebrations in a different light. When we detect these far-off supernovas, we're not witnessing them unfold in real time. We are instead seeing the echoes of their grandeur from a vast distance. This shift in understanding challenges us to reflect on our place in the universe and the role of time in our observations. Each successful detection of a distant supernova is less about witnessing a current event and more about piecing together a cosmic history from the fragments that have traveled across time and space to reach us. What are your thoughts on the ethical implications of colonizing other planets? Don't forget to like, comment, and subscribe to join the conversation and stay updated on our cosmic adventures.